Hello. Okay, I believe I am live now. Can someone confirm if I'm live or not? Okay, audible, sorry. Shang says audible. Hi, Shang. Good to see you back. Okay, cool. Let's wait for a couple of minutes for people to join. Is the audio perfect? Like, is it audible or like, do I need to increase the audio or something? Mukul says not audible. Mukul, I think it's an issue on your end because everybody else is able to hear me. So just check. Okay, let's wait for a minute for people to join. And in the meanwhile, I'll just see if I have all the codes. Okay. Sir, it says it's fine. Okay, perfect. I only see 6 people watching. Why is that? Like, usually there are like 25, 30 people at this moment. Why do we have less people? For people wondering, we are actually going to solve the first 6 problems, which are these 6, and maybe we'll discuss the last problem as well. Okay. All right. Let's wait for some time for people to join. I only see 5 people watching. Is there some issue or somewhere like why do we have less people today? Notification नहीं आती है. Okay, we have 10 watching. That is again very less. Okay. So maybe because of weekend. I would say like because of weekend there should be more people, but for some reason there are less people. In the meanwhile, I'm just like copy pasting my code of HTML tags. I forgot to copy paste that. Okay. Okay, I think I should start even though I have very less people today. Okay, cool. All right. So I'll first tell everyone about. Okay, yeah, cool. Okay, so I'll first tell everyone about the Unacademy subscription, which I forgot today. Where is it? Okay, here it is. So I believe everybody watching this video or the stream already knows about it. If not, maybe you're the first time coming to this channel, then I'll just let you know about it. So Unacademy has a subscription plan. Okay, before that, let me tell you a little bit about me. My name is Naman. I am SD1 at Adobe. Before this, I was working as a member technical at D-Show. I used to be a candidate master on Codeverses. Right now, I myself am a expert. On CodeChef, I am a 5-star. Then I take subjects related to competitive programming, data structures, algorithms, and etc. So, what is Unacademy subscription? Unacademy subscription lets you access all the batches on the platform. So, before moving on to subscription, I'll tell you about the batches. So, in the month of June, we launched 4 batches actually. these are the 4 batches that we launched. One is a clubware, which is specifically for people who want to learn data structures and algorithms in Java. Okay, so that started on 15th June. Then we have Python Expert, which is for people who want to start competitive programming in Python. Then that also started on 15th of June. Then we have Brahmastra, which is a 6-month course and is specifically for people who are preparing for interviews. And then we have Adroit 2.0, which is a 9-month course and which is a 9-month career readiness batch for beginners. Okay, so these are the general offerings of Unacademy, which everybody knows by now, I believe. Then this is a subscription plan. So the good thing about this is that if you use my referral code, which is NBYT, you are actually going to get a 10% additional discount on the subscription plan. And these prices are actually after the discount. So if you look at this 12-month plan, the original costing of this is actually somewhere around 33k, and like if we remove the 10%, we get 29,700. So if you're thinking about getting the subscription, make sure to use my referral code. Okay, and you can also follow me on the Unacademy platform. The URL for that is unacademy.com/namanbansal013. So yeah, you can use that as well. So this is all about the subscription plan. All right. So we are going to solve the first 6 problems today of Div 3, which are these 6 problems, and then maybe we will discuss node marking as well. But before that, I would actually like to know like how many questions you were able to solve, like who was able to solve how many problems. There are many people who are regular on this channel now, so I kind of am able to keep a track of those people. So I'd love to know like how many problems they were able to solve. All right. Okay. And yeah, in the meanwhile, I'll also tell you about how I did. Okay, I need to go to Div 1, Div 2 for that. I myself had to give Div 2 because my last month's lunchtime went really bad. So I myself was slipped down to Div 2. I was able to do the first 4 problems, which are actually the like second, third, fourth, and fifth problem. No, sorry, second, third, fourth, fifth, and sixth problem. And then I kind of struggled in node marking. I got a partial on it, but I was trying for a bigger partial for it, and I wasted all my time on that. And I believe my solution is right, but somehow it is giving a wrong answer. But I should have like spent a little time on getting a partial for hidden cell as well. Okay. Ishan says first 5 questions. That is really nice, Ishan. Jibban says 4, Mickey says 2, Vansh says 5, Sare says 3. Okay, that's perfect. Okay. So we'll have different problems for people. Ishank will get to know the solution of 6th problem. Jabin will get to know the solution of the 4th and 5th problem, 5th and 6th problem, and so on. Okay, so yeah. So should I start or should we wait for more people to join? I only see 14 people watching. That is really low for this type of stream, but I don't really know like what's the issue today. Amit says 4. Okay, cool. That's perfect, Amit. But yes, today's contest was kind of balanced, I would say. Like we have a balanced number of submissions today. That's really nice. That is not something you usually see in lunchtime or any of the CodeChef contests. But yeah, that's really good for today. Okay, I'm gonna start now because I don't really think many people will join. Okay, so let's start with the very first problem, which is Richie Rich. Okay, so Chef aims to be the richest person in Chefland by his new restaurant franchise. Currently, his assets are worth $1 billion. So he already has $1 billion. Okay, so he has $1 billion and have no liabilities. He aims to increase his asset by X billion dollars per year. So basically, per year he gets an addition of X billion. Okay. Also, all the richest people in Chefland are not planning to grow and maintain the current worth. Okay. To be the richest person in Chefland, he needs to be worth at least $B billion. So he needs to reach B billion by these additions. How many years will it take Chef to reach his goal if his values increase by X dollars per year? Okay, so if you see, this is also given that X divides B minus A. So basically, as you can see, in order to reach B from A, you need an addition of B minus A. And to do that, for every year, you are getting an addition of X. So if we divide this by X, you get the total number of years that are needed to reach from A to B. And since it is a like x divides b minus a, we don't really need to check if like any mod conditions here, and we can just print the value of b minus a by x. To make it more clear, I'll just quickly show the code. So this is the code for this problem. So basically for every test case, I'm scanning a, b and x. I scan c and a, b and x. Then I just print out b minus a by x, and that is it. So I am pretty sure like this problem is something which was everyone was able to do. Okay, and let's not waste time on this problem now. Let's move on to the second problem, which is false number. Okay. So the next problem says that one day chef's friend gave him a wrong number w containing n plus 1 digits and said that the actual number a is the largest number that can be obtained from deleting exactly one digit of w. So basically we're given a number w, okay, and it has n plus 1 digits. Now he deletes one number, deletes one digit, he deletes one digit, n plus 1 digits, and said that the actual number a is the largest possible number that can be obtained from deleting exactly one digit of w. So he gets a after this, and this a is the largest value possible. Okay, now that can be obtained from deleting exactly one digit of w. Okay, chef was able to find a but forgot w. So now he knows this, what is this value of a, but he forgot this w. Okay, given a, find the smallest possible number w of length n minus 1 without leading zeros, that is consistent to the story above. We can show that there is always at least one such w consistent with the story. Okay, so let's look at some examples. Okay, so let's look at the very first example. Let's say, so the very first example is 9, 8, 7, 6, 5, 4, 3, 2, 1, and 1. Now we need to add one digit to this at any place such that if we remove that digit, this is the largest possible value. Okay, so the solution is very simple. Okay, let's me kind of try to explain like for every position. Now since we need to add one digit and the result number needs to be the smallest number, find the smallest possible number w. That's why we know that we can either add 0 or 1. The reason why we cannot add 0 every time is because we cannot add 0 here. So if we have to add like any value in the very first place, then we'll add 1. Otherwise, if we have to add a value at any other place, we'll add 0. That is clear, I hope. Okay, now let's see. So basically we can either add 1 here or we can add 0 at any of these places, right? That is clear. So let's try to see like what are the possible ways. So to make this a little easier, what I'm actually going to do is I'm going to make this value a little smaller. Let's say the value that we had was 98. Okay, now what are the possible values? We can have 198. If we add 1 in the very starting, we can get 908, we can get 980. These are the only 3 possible values, and since we had to find the smallest value, we can see that this 198 is the smallest value. Okay, so basically, okay, let's take another example. Let's say we had 15. Now let's try to do the same thing for this 15. We can either have 115, we can have 105, or we can have 150. Now if you see, this 105 is smaller. That means we had to add a 0 here. The reason is because if we add 1 like at this position, this whole number gets shifted by one place, but we can actually add the 0 and we can get a smaller number. Okay, so I don't really know like how to explain this in a better way, but yeah, the logic for this is that if the very first value is 1, then we have to add a 0 after that. But if the first value is something other than 1, then we can just add a 1 in the starting. Okay, so if I show the code for this false number, yeah, so that is all what I have done. So basically what I've done is I've just taken the length of the string. Then if the very first value is 1, then I first print the first index, which is this one. Then I print a 0. Okay, and then I print the rest of the string. But if the very first value is not a 1, sorry, is a 1, sorry, what am I saying, is not a 1, like for in this case we had a 9, what I have to add is I have to add 1 before that. So basically what I do is I straight away print 1 and then I print the very first index, and then I'm printing the complete rest of the string. Okay, so I believe this is also clear. That again, there was not much to do in this problem as well, and I'm like, I can see like everybody was able to do this problem, at least the people who are watching the stream right now. Okay, cool. So should I move to, okay, I believe this is clear to everyone. Sumit says, sir, can you tell the reso? I don't really understand what you're trying to say, Sumit. For 0 and 1, I don't really know what you're trying to say, Sumit. Okay, all right. So let's move on to the next problem now. I'm not wasting much time on the easier problems because I can see that everybody was able to do those problems today. All right. So let's go to HTML tags now. Okay, so the problem says that in addition to CP, Shiv recently developed an interest in web development and started learning HTML. Now he wants to create his own HTML code editor. As a subproblem, he wants to check if a typed HTML closing tag has a correct syntax or not. So basically, he wants to check if the type like string is a correct syntax or not. What is the correct syntax that is given to us? Okay, just a second. Cool. All right. So yeah, for the correct syntax, it must start from, okay, let me rub this. Okay. Okay, so for like a string to have a correct syntax, it should start with a slash, like what do we say, with this bracket and a slash, and it should end with a bracket as well, and it should have a non-empty body, and it should be what, alphanumeric. So basically with the lowercase, so the value should be lowercase, and or they should be like digits, we can say. Right, I believe the problem is clear to everyone. If it is correct, if the syntax is correct, then we can say success, otherwise we can say an error. Okay, cool. So how to do this? So basically the idea is very easy. Like we just have to brute force for the entire string that we're given. We need to first check if the starting is with this and ending is this, and then for every like character in the middle, we have to check that it should be either a lowercase or a digit. Okay, the way to start this is basically we need to first find out the smallest length of a tag. So we need to start with this, like this bracket and a slash. It should have a non-empty body, so we'll have at least one value here, and then it should have a closing tag. So basically the smallest string will have a length of 4. So if I show you the code, what I've done is I've actually written that for every string in every test case. So I have taken n as the length of the string. So this, if this n is less than 4, I just print error and then I say continue. Okay, so that I can rule out all the cases in which the length is less than 4, then they're obviously an error. Okay, after that I check the start and the end. The start should be this bracket and a slash, so I'm checking that, and then I'm checking that it should have a closing tag as well. If any of these conditions fails, then we can say that it's an error. Otherwise I just check the complete body. So you could actually write the function, like write the, like what do we say, conditions for that, but maybe you don't know there are like predefined functions for that. So basically to check if a character is a lowercase character or not, we just need to write is lower. For a digit we can just write is digit, and similarly for the uppercase also we have is upper also, but that was not needed. So yeah, I just did that. If it is fail, like if it is like not any of these, then I just make the flag equals to 1, and if this flag is equal to 1 in the end, I just print the error, otherwise I print success. Again, kind of a easier problem. We just had to like write some code in this, nothing to like really think about, and I believe everyone was able to do this. If not, you have the solution now. Okay, I hope this is clear to everyone. I don't see many people like having a chat today. Like maybe it's because there are less people watching today. We have 24 people watching right now, so maybe that's the reason. But yeah, why are people not commenting anything in the chat? Okay, cool. So let's move on to the next problem, which is unpleasant ones. This is kind of a fun problem. I would say like a very easy but a fun problem. Okay, so let me rub this. Okay, Shivam says fourth one was tricky. Yeah, we could say that. Okay, Sumit says yes, clear. Okay, perfect. All right. So without further ado, let's move on to the fourth problem, which is unpleasant ones. Okay. The ugliness of the string is defined as the count of two consecutive ones. Okay, so basically, if we have two consecutive ones, Atisha says n less than 3 question mark. Uh, n like I'm writing n less than 4 because it is given in the problem that it should have a non-empty body. Okay, that's why I've written like, so basically we'll have at least one character for a tag. Okay, all right. Shivam says fifth one was tricky, fourth one was easy. I don't really remember. Fifth is from rational to binary. I don't really remember this question what it was now. It was okay. Yeah, we could say that. All right. Anyways, let's move on to the fourth problem, which is unpleasant ones. The ugliness of a string is defined as the count of two consecutive ones, one in the given string. So basically, if a string has consecutive ones, then we can say it is ugly. Okay, or maybe we just have to increment the count of ugliness. Okay, so for example, the ugliness of 10111 is 2 because it has the two consecutive ones here and two consecutive ones here, therefore the ugliness becomes 2. Now you're given an array A of n integers and you have to find any ordering of the array such that the ugliness of the concatenated string of the binary representations of the number without leading zeros is minimum. Okay, basically what they're trying to say is that, okay, what they're trying to say is that, let's take the very first example. So we have three numbers which are 3, 6 and 5. So we have 3, we have 6 and we have 5. The decimal represent. Okay, am I live now? Yeah, it's still buffering. Shivam says many people are saying buffering. Okay, really sorry for this, but am I live now? Yes, Ashank says yes. Okay, cool. So I don't really remember like I know how much you were able to see. So I'll just start. Okay, so basically there are 4 cases that we need to consider. One is even, odd even, and odd. Okay. Okay, cool. Okay, so okay, I hope this is not buffering now. Okay, cool. So let's consider the very first case, which is even. So we know that an even number is actually of the form, we'll have a 1 in the starting, then we'll have some numbers, and then we'll have a 0 in the end. So I'll write two even numbers here. We have 1, then some numbers 0, then we have again a 1, then some numbers and a 0. Okay. Now, if you see in this, if you basically see in this, the total ugliness of this string is actually the ugliness of this portion, like not this portion, which you cannot avoid because this is a complete number, and the ugliness of this portion. But this portion, which is the connecting portion of this, is not adding to any ugliness. Okay, so basically if we have an even number after an even number, that won't add anything extra to the ugliness. Okay, cool. Now let's come on to even odd. So if we have an even odd case, we have 1, then some numbers, then we have a 0, then for odd number we have 1, then some numbers, and the last value will be 1. Now if you look at this, again the same thing will come. We'll have some ugliness from this value, but that is the constant value. We cannot change that because this is a complete number. And we'll have some ugliness from this string, but the connecting portion is not going to add to the ugliness because it is 0 and 1. Now let's come on to odd even. Now if you look at odd even, we have 1, then some numbers 1, which is an even number, then for even we'll have 1, then some numbers and a 0. Okay, I think my screen. Okay, I'll just okay, cool. I'll just make myself a little smaller. Okay, cool. Okay, so if you try to see in this, we have some ugliness from this portion, some ugliness from this portion, but since it is a 1 in the end and it is a 1 in the starting, this will also have ugliness. So an odd even case is going to add to the ugliness. Now let's look at odd odd. For an odd odd case, we have 1, then some numbers 1, then again 1, then some numbers and 1. So again, we'll have some ugliness for this as well. Basically, what we get to know from this is that, what we get to know from this is that we need to avoid odd numbers after an even number. Okay, but in order to avoid these, how many odd numbers can we avoid? If you see, if an odd number comes, it actually tells us that the last value should be odd. If there is an odd number in the complete array, we will have the last value as odd, because that will decrease the ugliness by 1. Okay. Arun says off. No, Arun, I don't think I am off. I think I'm live now. I'm still live, I think. Are others also feeling the same? Yes, okay. Okay, cool. Okay, so basically the condition is that we will have an odd number in the end. Apart from that, we cannot really do anything else, because an even number won't add to the ugliness. We can see that, because even if it's an even number after that or an odd number after that, it is not adding to the ugliness. Okay, and for an odd number, we can say that it is adding to the ugliness, but we can only remove one number only. Okay, so that is the complete thing. So basically, all we need to do is, in the complete set of elements, we just need to find one number which is odd and take it to the very last index. All the other numbers can remain whatever place they are. So basically, if I take the example of the very first input, which is 365, there are multiple answers for this. One answer would be we can have 3 in the end, so we'll have 65. The other answer will be 563 also, because we have 3 in the end, or the what do we say, 3, 5 and 6. Then the ugliness will increase by 4, because now this 5 and this 6 are going, the end points of these are also going to add one ugliness, and in total we'll have an ugliness of 4. So is this understandable to everyone? Is everybody able to understand what I'm trying to say here? I'll even show you the code so that it's more clear. So basically how I'm implementing this is, in why can't we place even, odd, even? We can place even, odd, even. We'll have to place even, odd, even, because there are many odd numbers. But if you see, whenever we place an odd number before any even number, or an odd number before any odd number, it adds to the ugliness, because it is ending with the 1. Therefore, we'll have one extra ugliness. Therefore, we need to avoid odd numbers in the middle. Okay. Therefore, I'll try to bring the odd numbers in the last, but I can only bring one odd number in the last, because if I bring 2 odd numbers in the last, then if I bring one odd number in the last, but then I bring another odd number in the last, if I bring one odd number in the last and then I bring another odd number in the last, this number is not the last number now. This is the only last number now. So basically, in the last, I can only have one number. Okay, so basically that one number should be an odd number. And then you can even take a look at this. All these cases have the same ugliness, because all these values are ending with an odd number, but this value is ending with an even number. Therefore, the ugliness of this is 4. Okay, and this is the code for this. So basically, after scanning the complete array, what I'm doing is I just check if this index is the value at this index is an even number, odd number. If it is, I just swap it with the very last value and break it off, and then I print the complete array. Shivam says I printed all the even numbers first and then all odd numbers. It works. Yes, it will work. But I think I would say that that is not the logic of that. The logic of that is that the last value should be odd. Apart from that, every other number can be anything. Only the last value should be odd if we have any odd value in the complete array. Okay, so that is all that we had in this problem. I hope this is clear to everyone now. Placard says, is this a greedy problem? Kind of, yeah, it is a greedy problem, we could say. But yeah, it's more like a tricky problem with a very easy condition. Not really any algorithm. We cannot really divide this into any algorithm or something. This is just some observation, I would say. Okay, cool. So I hope this is also clear to everyone now. If yes, we can move on to the next problem, which is from rational to binary. Okay, this is a good problem, I would say. Yeah. Okay, so all right, cool. Okay, there are Only 736 submissions. Okay, cool. Okay. Atisha says, can you explain once? I could, Atisha, but yeah, I would say it's better if you can just go a little back in the video and see the explanation again after the end of the stream. Okay. You can just skip this problem for now. You can like learn the other problems and then you can go back and then you can just try to understand it again. It's a very easy logic, I would say. Okay. So yeah, if you are not able to get it, you can just go back and try to understand again. But yeah, you can just keep the stream running. You can listen to the solution of all the other problems and then you can go back. Okay. All right. So I'm going to start the solution for, like the explanation for from rational to binary now. So the problem says that Chef and Divyam are playing a game. They start with the rational number x such that x is greater than 0 and less than 1. Okay. So if we, okay, let me just write it. Ishan says if you use fast cin, then it won't give TLE. For which problem is it? Regarding the fourth problem, we have yeah, I think you should use fast because there is a large input. Okay, cool. There is a large input and there is a large output as well. For input and output streams to null, this 0 is nothing but null. Otherwise the input stream is actually bound to like the output stream. That's why like it takes a little extra time, but if you tie them to null, it doesn't really print anything in the buffer memory. It prints right away. Okay, so yeah, that is the reason why we use these two lines, and I think everyone should know that, like why we use this. Okay. Okay. All right. So let's move on to the next problem now. So Chef and Divyam are playing a game. They start with the rational number x such that x is greater than 0 and less. So basically, then Divyam either adds or wins. So basically, if this becomes 0 or 1, then Chef wins. Okay. Now you're given x and you have to determine whether Chef can win in an infinite number of moves. More formally, does there exist a finite number n, so that Chef has a strategy that is guaranteed to win in at most n moves? Here x will be given in the form of a by b, where a and b are positive integers. So basically, since x is a rational number, that's why they're giving it in the form of a by b. Okay. Uh, Abhijit says I started CP. If you use okay, Abhineet says if I started CP this month and I was able to solve only one, feeling sad. It's okay, Abhineet. Like it's your very first contest. I remember in my very first contest I was not even able to solve one problem. So I think you did better than me. So yeah, that's okay, perfectly fine. Urusha says why are we swapping the last index in case of odd? Because we need an odd number in the last. That's why we are doing it. Okay. Yeah, you can actually, Abhineet, you can actually read the comment of Shivam. That's really nice. Okay, cool. Okay, so how to solve this? Let's take some examples. Okay, let's take the very first example. So in the very first example, we have x as 1 by 2. And I would say that's a really nice example. So basically we have 0 and we have 1. Now 1 by 2 will actually lie in the exact center. So if Shift has a 1 by 2, and if we makes y as also 1 by 2, then Divyam will either add this number or delete this number. Okay, if we add this number, then 1 by 2 plus 1 by 2 will actually make 1. But if we subtract this number, then this will actually give him 0. That's why Shift is able to win. Okay, so this is clear. Let's look at some other cases. Okay, let me make this a little bigger. We have 0, we have 1, we have 1 by 2. Okay, now we know that we are able to achieve an answer for 1 by 2. Let's look at 1 by 4. What happens if the value is 1 by 4? Okay, if if the value is 1 by 4, if x is equal to 1 by 4, we can actually make y as 1 by 4 as well. The reason is because if we decrease 1 by 4 from 1 by 4, it will become 0 and Chef will win. But if we increase, it will become 1 by 2. And from 1 by 2, we already know that we can get a solution. Therefore, 1 by 4 will also give a like success. Okay, or we can say yes. Okay. Now let's look at what is the middle of 1 by 4 and 1 by 2. It is 3 by 4. Sorry, 3 by 8. Okay, cool. So, okay, so I'll just continue from here. So if I take 3 by 8, if my x is 3 by 8, so basically what I'm doing is, what I'm doing is, I think I'm back live now. So what I'm actually doing is I'm actually finding the middle point of every two consecutive values. Okay, and similarly for this point also. So basically what is the half of 0 and 1 by 4? It's actually 1 by 8. So we'll have a solution for 1 by 8 as well, because we can either add 1 by 8 or subtract 1 by 8 when we will get a solution. Similarly, for 1 by 2 and 1, we can actually have an answer for 3 by 4 as well. Then again for like 1 by 2 and 3 by 4, what is the half of these two? It is 5 by 8. We'll have a solution for 5 by 8 as well. Similarly, we'll have a solution for 7 by 8 as well. Then again, we'll have a solution for the middle point of 3 by 4 and 7 by 8 as well. So basically, if you are able to see, we are actually able to divide the set into halves, and for every half, we are able to get the value, like get the answer. Now, okay, all right. To ensure this, if you actually try to see, the base will always be a power of 2. Okay. So so that's all you have to do. If the value is of the form x by y, all you have to do is just check if y is of the form 2 is of like a power of 2. If it is, then we can like have a solution for it. I hope I was live the entire time. I don't really know like when it's buffering and when it's not. I'm experiencing some internet connectivity issues. I'm really sorry for that. But yeah, I hope you're able to get the solution. So basically all you need to check is that y should be a power of 2. If it is a power of 2, then we will be able to find an answer for that. And this is the reason like why it works for all those cases. Okay, cool. So I am pretty sure like everybody was able to get this. It will be easier for me if someone. Okay, cool. What should be the rating of this problem if it was on good forces? It would be somewhere like around 1600, I would say. Okay, cool. Let's move on to the next problem, which is tic-tac-toe now. All right. Okay. So in this problem, we are given that two drunken players, Alice and Bob, are playing a modified version of tic-tac-toe. Initially, there is an n into m grid. So, okay, let's make an n into m grid. So this is n and this is m. Okay. And yeah, okay, that's all. Okay. Now Alice and Bob take alternating terms starting with Alice. In her turn, Alice chooses an empty cell on the board and puts an A on the chosen cell. In Bob's turn, he chooses an empty cell and puts a B on the chosen cell. Okay. The player who first gets any K into K subgrid completely filled with his/her initial wins the game. Okay. So basically, if like let's say this is a grid of K into K in this complete grid, and if every letter inside this is an A, then we can say Alice wins, or if every letter in this is B, then we can say Bob wins. Okay, but the player who gets first K into K grid, okay, so basically we need to look for the person who is the very first person who got it like K into K, okay, not the very last person or someone else. Okay, so yeah, you're given the sequence of moves played by each player. The cell selected by this player in his turn. You have to output the winner of the game or report that there is no winner. Okay, so let's just try to look at how a general grid is going to look like. So for simplicity, what I'm actually going to do is for Alice, I'm going to write 0, and for Bob, I'm going to write 1. Okay, so that we don't have to like use any characters for this. Okay, so let's say okay, so basically we're given all the n into m terms. Okay, so basically we're given all the terms initially only, like who played what, like who played what turn. Okay, So let's say that in the end we had multiple k into k grids. So let's say this was a k into k grid with all zeros, okay, and so on. Then let's say this was one other grid with all ones, and let's say this was another grid with k into k with all ones, and so on. Okay. So Surjit says I'm able to solve first four questions in today's contest, and that rational to binary one. Trying to find out if the given input is non-terminating decimal or not, and always it will give me TLE. Not really able to understand what you're trying to say. Today's notification also did not come. Okay. Shivam says we cannot see the code of the last problem in the scene. Can you show it again after the problem gets completed? Yeah, Shivam, I'll definitely show the code. Okay, cool. Okay, so let's coming back to the same problem now. This problem now. Okay, so let's say in the complete grid, we somehow were able to figure. What we can do is we can actually. Okay, it's buffering again. Okay, so what we can actually do is, if we know like what all like grids are working, we can actually find out which out of all these. So basically it will have k into k turns. We need to find out which was the last turn taken by Alice to complete this grid. Let's say at xth time this grid was completed. Then again for this grid, let's say at yth time the last one of this k into grid was written. And similarly for this grid as well. Let's say for zth time the last one of this grid was written. Since this is also for a Bob and this is also Bob, we can find out the minimum out of x and y. Let's say so minimum out of y and z. Let's say y is smaller. That means this grid got completed earlier than this grid. That means this grid might give us a solution. Now we have one grid for Alice, one grid for Bob. We just need to find out whether x is smaller or y is smaller. If x has a k into k grid. Okay. Now how to do that? So to do that, I'm actually going to a prefix grid of this. So basically, let's say this value at this cell is actually going to contain the sum of all the values of like all the cells before this. So basically every value in this grid, the sum of every value will be here. Now when we let's say I make this prefix grid. Okay, after that what I need to do is but this can be of any length, but I need to only look for k into k grid. So basically what I do is I actually make a k into k grid. Okay, now in order to find all the values in this, now since I have made that Alice will have a 0 value and a Bob will have 1 value. If somehow I'm able to find out the sum of all the values in this like grid, then if the sum is 0, then I can say Alice like has a grid here, or if the sum is k into k, the values of this complete grid. What I can actually do is okay, so let's say this is, then I can say this is a k into k grid of Alice. If this sum is equal to k into k, then I can say this is a grid of Bob. Okay, I can see I'll just explain this part again. So basically what I'm doing is, this block contains the summation of all the values of this entire grid. So that is my Aij. I need to find out the summation of all the values in this k into k grid. In order to do that, what I'm actually going to do is I'm first going to subtract the value at this block, because the value at this block is going to contain the sum of all the values in this block. So that is basically a of I minus k into j. So that is a of I minus kj. Then I'm going to subtract this value at this block, because the value at this block will actually be the sum of all the values of this block. Okay, so that, and the indexes of this is I comma j minus k. So I subtract a of I and j minus k. Then if you see, while subtracting this block, I actually subtracted this block once, and for this block also I subtracted this block once. So basically this block is subtracted twice. So I need to add the value of this block, and the value of this block will be present at this index, and this index is I minus j, j minus k. So I add a of I minus j and j minus k. Now if this ij comes out to be 0, then I can say this block has Alice. If this sum comes out to be k into k, then I can say this block has all Bob values. Okay, so I hope this formula is clear to everyone. So basically what I do is I take, if it is equal to 0, I have made a vector of for Alice. I just push the indexes of I and j in that vector, saying that this is the place for Alice where Alice wins, and similarly for Bob. Then for every winning position of Alice, I find out the maximum time it took to complete that grid, and similarly for Bob, and then I find out the minimum out of these. So basically, let me just show you the code. It becomes 1. If it is 1, it became. I'm really sorry for this, but I don't really know what I can do for this. Okay, cool. Anyways, so basically now this is the part where I'm actually finding out the prefix array of the complete array. Then this is the part where I'm actually finding all the winning positions of Alice and Bob. So basically in this sum, I'm able to find out this value. So basically I'm marking this as sum, and in this sum I'm able to find out this value, and then I see if it is equal to k into k, then I can say it is a winning position. This I and j is a winning position for Bob, so I just push back into the Bob array. Otherwise it is a winning position for Alice if the sum is equal to 0. Okay, now what I do is I first iterate for all the Bob indexes. All they do is I first iterate for all the Bob indexes, all the indexes where Bob was winning. So for every index, what I'm actually going to do is I'm going to so let's say if this is ij and let's say Bob won for this ij, then I iterate all the values in this index, all the values of timestamp, because I have also saved the timestamp of every turn, and I try to find out the maximum time for any index that was taken to fill, which actually gives me the timestamp of the last b that was stored in this grid, and that is exactly what I want. And then I use that to find out the minimum time that Bob took for any given grid. So basically in this for loop, I'm trying to find out the minimum time in which the first k into k grid was completed. And then I have the same code for Alice, in which I'm trying to find out the minimum time in which Alice got its first k into k grid. Okay, then after this, I just check if Alice min and Bob min both are equal to int max. That means none of them were able to get a grid of k into k, and I can just say it's a draw. Otherwise, if Alice min is less than Bob min, I can say Alice wins, otherwise Bob wins. Okay, so that is the complete logic of this one. I'm not really sure how many people were able to understand it completely, considering the lag I'm experiencing and the buffering today. But I'm pretty I hope in the recording it won't show that much. Okay, but yeah, I think for the last part I was live, so can I have a yes or no from the people if they're able to understand it? Otherwise I'll just quickly go through the approach again, or you can just look at the recorded video as well. I'm pretty sure it will have the complete stream. Okay, all right. I kind of had made plans to discuss the last problem as well, but I don't think it's a good thing to do considering the connectivity issue I'm facing. So yeah, anyways. Okay, I don't have anyone in the chat. I'm still buff. I'll go and understood. Okay, you can just go back into the video and look at it. Please explain once again, Amit says. Okay. Okay, I'll just try to explain it one more time, but I'm not really sure if I'll be live on stream. Yeah, okay. So I believe my code is visible to you at least.